This is Mr. T, and we have a tutorial today on solving logarithmic equations. I've outlined the steps that we'll use to solve the problems here. We want to get the log terms on one side of the equation and any constants or numbers on the other side. We'll then use our logarithm properties if there's more than one log to condense it into a single log statement. So now we'll have log of something equals a number. We then use our conversion to convert that to exponential form and solve the equation. When we're solving logarithmic equations, we need to check or verify for extraneous answers because the domain of the log function is only positive numbers, so if we come up with a negative value of x, we can't use that as an answer. We can check for extraneous answers not only by verifying that we don't have a negative number or zero, but we could also plug it back into the original equation and check it out. Let's go through one example here. So we have our problem at the top, 25 equals 4 log x plus 1. Remember, the log without the subscript is a base 10 log, the common log. So we're going to subtract the 1 and divide by 4. So when I subtract 1, I get 24. I divided by 4, I get 6. We now convert that to the exponential form, so we get 10 to the 6th power equals x. So we now have it solved because 10 to the 6th is a million. If we plug a million back into the original problem, we are going to get 4 times 6, 24 plus 1 is 5, so it's going to check out. In the next segment of the tutorial, we'll go through several more examples. Okay, I've written 2 more examples on our board here that we can solve. So our first step was to get the log by itself. On our problem over here, we can see we have the log by itself. Our next step is to convert to exponential form, so this will be 5, and then this becomes our exponent. And what we were taking the log of becomes what the exponential function equals. 5 squared is 25. And now we have a simple linear equation to solve, so we're going to subtract 1 and divide by 3, and we get 8 equals x. This is not a negative number, so most likely this is not extraneous, but let's just check our work anyway. So let's plug that back in. So log base 5 of 3 times 8 plus 1 gives us the log base 5 of 25. And remember to solve that using our mental math. We are going to convert 25 to 5 squared, and inverse operations of logs and exponents tells us that this equals 2. Which matches our original problem, so that checks out. Okay, let's look at the one on the right. We have our logs on one side of the equation and numbers on the other. Our next step was to condense our logarithm, so since we have plus here, we will be multiplying the things that we're taking the log of. So now we get the log of 5x times x minus 1. Now we could distribute now, but we'll do that in a minute. Now we convert this to exponential form. Remember, this log is a base 10 log, so we get 10 squared equals 5x times x minus 1. We have when we expand this out, we have a quadratic equation. Now we can divide this equation by 5 to reduce the numbers. And remember, quadratic equations, we want to set equal to 0 and try to factor them. Or if we couldn't factor, we could use the quadratic formula. Here this factors into x minus 5 and x plus 4. And using our zero product property, we have 2 solutions, 5 and negative 4. Now these are potential solutions. They could be extraneous. If we look At the negative 4, if we plug that back into 5x, we're going to get log of negative 20, and we can't take the log of a negative number, so that's extraneous. Let's check out the 5. So if we put 5 into the original problem, we've got the log of 25 plus the log of 5 minus 1 was 4. We can use our logarithm property to make this be log of 100, which is log of 10 squared. And using our inverse properties, we get 2, which matches our original problem, so that checks out. So this problem had a single solution of x equals 5. I hope these two examples help you out.